The benzenes are in desperate need of nitrogen to feed their crops, but they can't get it out of its very stable diatomic state. However, it looks like this benzene has had an idea to use fire and pressure to break the bond. The benzenes need food to survive. Although aromat is arable and provides plenty of food, the benzene population is always growing. If they grow crops for too long using the same soil, they will deplete it of all the nutrients required for plant growth. They need to develop a way to get nutrients to the plants. One of the key elements plants need for growth is nitrogen. At the face of it, this looks easy to get as air is approximately 7 to 8% nitrogen. The problem is, nitrogen exists in a very stable diatomic state held together with a triple bond, meaning there is no motivating circumstance for the nitrogen to react. The benzenes need to find a method to deliver the nitrogen to the plant in a way that will allow it to react. The benzenes have discovered a natural source of fertilizer. Over hundreds of years, colonies of seabirds on islands have produced large mounds of white excrement. This waste is a highly effective fertilizer due to its high content of nitrogen, phosphate and potassium, all key nutrients essential for plant growth. The benzenes mine this waste and spread it on their crops to help them grow. However, although this is a natural resource, the benzenes are consuming it faster than it can regenerate. They need to find another solution. The benzenes have developed a chemical process to allow them to take nitrogen from the air and form ammonia, which can be used to make fertilizers. The first step in their process is called catalytic steam methane reforming. Using relatively high temperatures and pressures, the benzenes can get methane to react with steam. This produces the first ingredient required to make ammonia, hydrogen, as well as carbon monoxide. The reaction takes place in a reformer. Here the reactants are heated to 800 degrees Celsius using natural gas burners and are pressurised to 25 bar. This reaction requires a high activation energy to proceed. The benzenes make use of a nickel-based catalyst to lower this energy. This allows the steam to react with the natural gas. The primary reformer will not convert all of the methane. A secondary reaction is required to achieve a higher conversion rate. Here, air is added to react with the remaining gas. Air comprises of approximately 78% nitrogen and 21% oxygen. The oxygen reacts with the remaining methane to form carbon monoxide. This reaction takes place in the secondary reformer. Here, oxygen is added through the addition of an air stream. This also introduces the nitrogen required for the formation of the final product, ammonia. The next stage in the process is the water-gas shift reaction. Here, carbon monoxide reacts with water to form carbon dioxide and more hydrogen. This reaction is typically done in two stages. The first stage is a high-temperature shift reaction using an iron-based catalyst carried out at approximately 400 degrees Celsius, followed by a second stage low-temperature shift reaction using a copper-based catalyst at approximately 200 degrees Celsius. In this reactor, the water and the carbon monoxide enter at the bottom and flow through the stages of the reactor to form carbon dioxide and hydrogen. For the nitrogen and the hydrogen to react, the gases need to be at high pressures of around 150 to 250 bar. To achieve this, the benzenes use a compressor where the gases enter at the centre and are pressurised via the imparting of energy from the rotation of the compressor. The next stage in the process is to remove the carbon dioxide. This is achieved using a scrubber. The scrubber works by passing the carbon dioxide through porous beds of limestone particles sprayed with a continuous flow of water. The carbon dioxide then dissolves preferentially into the water, leaving just the nitrogen and the hydrogen. The carbon dioxide is then recovered to be used in other industries. This is one of the main sources of carbonation for beverages. Now that the benzenes have formed and separated the necessary reactants, they can proceed with the reaction. Here, the hydrogen and the nitrogen are reacted using a catalyst to form ammonia. The gases are passed over beds of an iron-based catalyst. This lowers the activation energy and allows the reaction to take place. On each pass, only about 15% conversion occurs. The unreacted gases will need to be separated and recycled back to the reactor to improve the overall yield. The gases leaving the reactor are at a high temperature, meaning the stream contains a lot of thermal energy. It doesn't make sense to waste this energy. The benzenes have developed a clever way to recover the heat. They pass the gases through a heat exchanger where the heat is transferred into water. This water then forms steam, which can be used elsewhere in the process or to generate electricity. It is now time to separate the ammonia from the unreacted hydrogen and nitrogen. The gases are passed through a separator which uses a chilled utility to lower the temperature of the gas stream. The ammonia has the highest boiling point of -33 degrees Celsius, therefore it will condense out of the stream first. The liquid ammonia then collects at the bottom of the tank before being pumped to a pressurised storage vessel. The unreacted gases are then fed back to the reactor to go through the process again. The ammonia can now be shipped to other plants to be manufactured into fertilisers. It is also useful in the production of plastics, fibres, explosives and nitric acid. The benzenes have built a key intermediate chemical that will go on to make many other useful chemicals. As you may have seen, the process the benzenes use relies heavily on methane, not only as a reactant but as a heating source for the reaction. This is very carbon intensive. In the future, they will need to look at other ways of getting the hydrogen for their process that are better for their planet, Aromat. The benzenes are new to YouTube and want to keep sharing their journey of understanding with you. If you want to see more, consider hitting the subscribe button.